parts out for this on the plasma table. We've got to either oversize all the holes or spend a lot of time after we cut cleaning them all, reaming them out with special tools. I usually can cut all the parts for a job like this in a day, but then you add another half a day on the back end, cleaning everything, making it be able to fit after the fact. So we're really excited to have that, to be able to just cut it quicker and not have any cleanup after the fact.
So even if it cuts the same speed as the plasma table, you're still making up time?
Oh yeah, or even slower. I mean, you'd still be time ahead without all the cleaning and all the processing after the cutting's done. And sometimes halfway through, you know, you get a sharp edge or a bows on you and you get a weird cut, and just quality control is, we'll have to spend more time cleaning that up after. Where the other foot is?
That one right there. Christmas came early.
Yes, it did. Operated plasma or anything before, how long do you think it would take to train somebody?
I mean, you're about like an hour to be productive with something that you already have set up in here. Mm-hmm. And then to like set up a new parameter from scratch, that's probably like a couple months. Just
to run, open up programs and load material and run it, a couple hours.
Yeah, a couple hours.
But it's just learn on the job as you go.
That's how we've done it. Is like we get them productive, and then kind of let them loose, then let them get stuck.
Yeah.
And then we'll jump in there and show them some more tricks.
Cool. So this is about the limit then on
with air.
Yeah, on mild steel. You can air cut 1/4 inch aluminum though. So, and the 1/4 inch stainless also on shop air.
Is there a chart?
Yeah, that's, we showed you guys the, so here, this is on the website, so you go to support, fiber laser cut charts, and then 2 kilowatt power. Because on mild steel, you're using the oxygen as an accelerant to get more out of the power, you know, and then anytime you're on air or nitrogen, it's all laser power is the only thing punching through.
So this might even have to get tweaked from cut to cut, or job to job, a little bit or not.
Not usually.
Not usually.
No,
Okay.
it's like if you're having to tweak it, it's because your lens is bad,
okay,
or your nozzle's messed up. Like, so it's like just switch the lens out, or your beam center. It's most commonly lens or beam center. That's your two.
So this is really
things
kind
to
of
check.
like kind of Bible. You look at that. That's where you need to set.
That's where you need to start, and then like that's why we've gone through and set up all these other materials for you and optimized them. Because this will like get you cutting, but then when you really want to clean up the edge, you got to kind of get off of this chart. All right, so we're ready for another file. You can draw right in the program. We're going to draw ourselves a little test rectangle here. Don't make it too big. And then we're going to select our cut parameters. We're going to load, yes. And then we're going to pick, what do you guys want to cut first? Oh, we already got oxygen set up, so let's cut our 1/2 inch mild steel. Bam, that's going to update all these cut settings. We're going to do this for you guys when we deliver the machine. We'll set up all the materials that you guys cut in your shop. Hit OK. We go ahead and frame our part out. That was a little low. Let's try this now. Frame the part out. That looks good. We're going to open our shutter. Laser's now live. Put on our glasses. Check our gas. Hit start. Quarter inch stainless here. So we're going to open up this stainless 1/4 inch shop air. You can get a cleaner edge with pure nitrogen, but we're going to cut this on shop air just to be fast and cheap. And then looks nice, crispy corners. But this is what I was talking about. This extra dross down here at the bottom is because we're cutting with shop air and not with pure nitrogen. It's also, the edge is oxidized. It's black, it's not shiny anymore, which eventually will cause rust. We usually cut on shop air because we're an architectural shop and we're having to match this number 4 polish on the top on the sides, and we're spending our labor dollars already grinding this down, so we're not going to spend extra money on nitrogen. But it will clean up that dross, and there will be zero oxidation on the edges if you cut with pure nitrogen. Here was the inspiration. I'm just gonna use this for B-roll. I mean, cue the porno music.
I mean, I would imagine like a 16 gauge would be so much cleaner, wouldn't it?
Yeah, aluminum.
Not tiny. That's tiny.
What?
But the aluminum has that kind of furry dross on the back that holds the pieces in pretty tight, especially on the smaller, these little smaller features. You're gonna need to like get a pick or something and push those out.
A lot of times you can take a sandpaper and just sand the back of it.
Oh, that's true too.
That way,
Yeah, then they fall because that fuzz on the back gets sanded off.
Incredible.
And it's so sharp. It's so sharp. Yeah,
That's awesome. That's awesome.
Yeah, now you'll start noticing your CAD design. If you have a little wobble, because the plasma cam process actually does an averaging process because it knows it has a 16th inch curve. So if there's a 30-second wobble, it'll actually divide that in half and spread it out for you.
Okay.
This machine, if you have a 30-second wobble, you're gonna have a 30-second wobble.
Here, I'm gonna go get a pick and pick all those letters out.
Oh my goodness.
Such sharp lines.
You guys got a laser.
That's right. That's right. We have a laser shop now.
Why don't you let him go get a pick?
Dying to play. We spent a lot of time on the software here, guys, because when I first started running lasers, the software was super complicated. The settings weren't in the machine, and I was on the struggle bus almost every single day just to get some product out the door. The complexity of the software should never be a bottleneck. We wanted the machine to be simple enough for any guy in your shop to be running parts on day one. Ready to run some production?
So that's the plasma quality
Okay.
on those. I mean, yeah, not great.
No problem.
Not great.
No
But
problem.
we can test it with this.
Okay.
What? What am I supposed
All right, so how long would this take you on a plasma table?
Probably 3 times as long, 4 times as long, and then you add in the cleaning time on top of that. So yeah, I mean, we're saving so much time. As you can see, that's the difference there. That's our plasma, and that's the laser. So plasma oversized burnt the holes out. The cut quality is not there. Bad pierces. So it's much different, much better. So we're actually able to do this job now.
How's that look?
But
Yeah.
I guess it needs to be okay for powder. We'll have to turn it down quite a bit when we're doing most of.
Ask you on etching, can you do just a single line etch instead of like the block letter etch? Just a single line?
Yeah, you just got to pick a font that just is single line.
When the setup takes longer than the cut, you know you're doing something right.
Yeah, definitely.
trying to get that EST out.
Yee.
You got a quarter?
Sheesh. That's nuts.
Maybe we ought to start producing pennies for the United States. The backside's not near as nice.
Oh,
You know, the blow through. But
Oh, on that small one?
yeah, on the teeny one.
I'm sure if you sanded
Yeah.
it and cleaned it
Oh
up.
yeah, look fine.
Here, give me that real quick. I'm gonna go run out. No, this. I'm gonna
Nobody cares about
take a sanding
No.
block over it.
Yeah.
Pretty warm. Still, that's amazing, guys. It really is. I mean, you could almost just etch that in there, right?
Oh, yeah.
Yeah, you can engrave.
and then you wouldn't have to knock any letters out.
For sure.
But it is pretty cool with it.
Not as cool when it's just engraved.
Well, yeah. Look, the bars came out. The bars that were cut out.
Yeah.
Welding came out pretty much.
Yeah.
That's insane.
I wouldn't have done that and said it was going to work.
No.
I'd have been like, I don't, there's only so much this machine can do. But these 1.5 and 2 kilowatt machines, you're gonna have to wear your laser safety glasses. Make sure you use the ones that we give you with the machine because it's different than your welding lens. It's not the same wavelength of light and it can actually get through a welding lens and still damage your vision. So please don't flame me in the comments section. Laser glasses! That's all you gotta do, it's that easy. And I don't want to avoid the elephant in the room, maintenance. These machines are designed to maintain easily because the more I have to come out to your guys' shops, the more money I'm gonna lose, okay? I do not make money off of a service contract. I make money by making good machines that I don't have to service. So the entire goal of this is that if we build quality machines that don't need service, I'm not gonna get a lot of calls, but I am on the hook for a 2-year warranty. So if head explodes on you, a resonator goes out, your motors need calibration, your water chiller stops working, I've got you covered for the first 2 years. You're gonna have a 0 cost maintenance contract with me and Hero Machine Co., making sure that your machines are always running. But down the road, all these machines are now networked with Wi-Fi, which means we can remote into your system, read the calibration and the configuration software that's on the back end of this. We lock it out, don't mess with the configuration software. It's bad news if you click one wrong thing, I swear. But we can remote in, diagnose your machine, and we can usually get 95% of them running just by remoting in. If something catastrophic happens, we will fly out to you and fix your machine and get you running again. We won't leave you stranded. A lot of guys still think fiber lasers are these delicate instruments that only belong in university labs. I want to tell you that is the older generation of CO2 lasers. 60% of a CO2 laser was actually a hidden prepaid service contract because they knew the machines were junk and they were going to cost so much maintenance that they just added it to the cost of the machine and hid that from the customer. But that's also the problem. The fiber lasers now require much less maintenance. They're way more robust. They just flat out run. You don't have any problems with these machines. But the old school dynasty guys like Trump, Amada, Mitsubishi, Mazak, all the big dogs still have their pricing structured for CO2 lasers, and the market has supported them so far. So Hero Machine Co. is about keeping these people honest and accountable and showing people what lasers actually cost today. These are not CO2 lasers. They're not the dinosaurs that take tons of maintenance. These are fiber lasers that are very easy to run, very simple to maintain, and you don't have to expect any hidden costs in there like you would a CO2. So finally, I hope you guys understand that we're not talking about the cost of the machine, we're talking about the cost of ownership. And if you calculate the cost of ownership, you're gonna be much happier and much more profitable with the fiber laser. We have all powers from 1.5 kilowatt all the way up to 20. We have all speed ranges from 1G machines to 2.5G machines, single beds, double beds, tube lasers, and we're also bringing in press brakes next month, so stay tuned for that. Thank you guys for hanging out. I hope you guys learned something. I hope you guys really think this is a cool machine because I've spent a lot of time putting it together and getting it here to this point. So please hit like, please subscribe, check out the website, heromachineco.com, and let's talk about your shop and what we can do to get you guys up to the next level.